Timothy Redaelli. I work in Red Hat in Italy for a networking service team. But this time I'm talking about open timestamp. So what is timestamping? Timestamping is a way to certify that a date of a document. In Italy, for example, you must do that with physical official. And but what about digital documents? So what is digital timestamping? Digital timestamping is based on a third-party digital signature. So you need a central certification authority. But this means you need usually to pay, it's closed, you need to trust, and stuff like that. So how can we use the blockchain for timestamping? So blockchain is like a linked list. So you have blocks that are connected one with the previous one. And so if you want to timestamp something, a file, a document, and stuff like that, you can just put the hash of the file inside a block. So you are sure that this hash exists at that date. Because a block is somehow have some hour of precision. So you are sure that at that specific day, the information already exists. Why using the blockchain? Because it's safe. Since you have lots of money on it, so people can't change it. It's open because anybody can send a transaction, can use it. It's cheap. I mean, the fee are some cents of dollar currently, so it's cheaper than pay somebody to certify your stuff. So what is open timestamp? So since blockchain is permissionless, I mean, you don't need to ask anybody to use it. Anyone could do timestamping directly. So open timestamp is just a standard way of doing timestamping without trusting anybody. So it was proposed by a Bitcoin Core developer, so Peter Todd. It's used by dozens of different companies. It's almost because in information technology you don't have infinite resources, scalable, because it uses Merkle tree. So Merkle tree is a binary tree with a mathematic cryptographic feature that it's created by hashing all the layers. So it means you can put almost infinite information in one Hercule tree, and you can verify it just by knowing the path of the tree in order to reach your information. So it means you can put all the timestamping you want on a single Bitcoin block in the case of Bitcoin, but this is not, you don't need to use Bitcoin. It's transparent. So Open Timestamp provides user multiple and easy ways to create and verify timestamp, because they created lots of clients and libraries for lots of languages, including Rust recently. So the key revocation problem. So if you sign a tag or something with the JPG, and later the key is revoked by you or expires, there is no way to be sure that the signature was really created at that time. So Git supports PGP signed commit tags, and it's used for security reason by almost anybody that uses Git. But you can't trust the old signature because an attacker can backdate the signature, and so you thought it was valid at that time, but it's not, because he rewrote the Git history, and he injected some bug or some worm, etc. Because this in PGP means nothing. I mean, there is nothing that prevents you to backward the date, to use an older date, both in Git and JPG. So PGP dates are only authentic as the key. So a revoked key or expired one can be used to forge historical signatures. So if you use Open Timestamp, you can verify that that commit exists on that date. So it means nobody can forge another signature. Since the Bitcoin blockchain is not accurate a second, but in hours, it's still good, because you don't need so precision in this case. So how to integrate it? You generate the standard signature like you have in Git. You generate the timestamp, append the proof after the signature. Because GPG doesn't care if you have another data appended to the stuff, to their signature. So in this case, you have without open timestamp, it's a standard commit. And then you have with the open timestamp, it's a standard commit with the appended the timestamp. So I thought about integrate it in RPM for the same region. Because if you downgrade a packet or something similar, you could be sure that the signature is okay. So this is some example of another usage. Okay. So if you have one question or some question, or we can meet later. Yes. Yes, so the question is how you can be sure that the signature is valid? Where is it? Well, so in order to do that, you need to download the header of the blockchain. You don't need the whole blockchain. Yeah, I mean, yeah, because the root of the Merkle tree is put inside the header of the block of the blockchain. So you have a Merkle tree on top of the blockchain Merkle tree. The file the tool generates includes all the informations that you need to walk the tree in order to validate that your information exists on that Merkle root. So you need all the adjacent hashes of the Merkle tree. Okay. One other question? We have 2 minutes. Okay. So if you want, I'm here. And also, you can read my information in the QR code or in this slide. Thank you.